Okay, folks, we're continuing with half-life. We're on page 31. So the definition of half-life, here it is: the time needed for half the atoms of a radioisotope sample to decay. And by decay, we mean to undergo transmutation. Okay, pause if you need to write that down. We start with one whole. After one half-life, we have half left. After another half-life, we have a fourth, because it's half of a half. Then next half-life, we have an eighth, half of a half of a half. Next half-life, we have a 16th, half of a half of a half of a half, etc. Okay, we're going to use table N to figure out some information about some different radioisotopes. How much time will it take for each of the radioisotopes below to decay to the fraction of the original amount indicated? So how long will it take some cesium-137 to decay to half the amount you started with? Well, look on table N. If you look on table N, the half-life of cesium-137 is 30.2 years. That's how long it takes for a certain amount of cesium-137 to decay to half the amount. So they're just looking for one half-life in this case. How long does it take some carbon-14 to decay to 1/4 of its amount? Okay, well, if we start at one half-life brings us to half the amount. The next half-life brings us to 1/4 of the amount. So 2 half-lives have elapsed. With carbon-14, table N tells us that the half-life is 5715 or 5,715 years. That's one half-life. That's another half-life. 5,715 plus 5,715 makes 11,430 years, or 2 times the half-life of carbon-14. How long does it take hydrogen-3 to decay to 1/16 of the amount that you started with? Well, you just draw it out this way. 1 to 1/2 to 1/4 to 1/8 to 1/16. When you're trying to solve a problem like this, it really, really helps to write out this chain of fractions: 1 to 1/2 to 1/4, etc., etc., etc. How many hops or how many half-lives passed to get to that 1/16? 1 half-life is the first arrow, 2 is the second arrow, 3 is the third arrow, 4 half-lives. It took 4 half-lives. So 12.31 years is the half-life of hydrogen-3. So that's 4 times 12.31 gives us 49.24 years, because it took 4 half-lives for that hydrogen-3 to decay to 1/16 of the amount you started with. If you start with 100 grams of cesium-137, how much will be left after 60.4 years? Well, we need to find out how long is 60.4 years in half-lives. How many half-lives have elapsed when 60.4 years have elapsed for cesium-137? Cesium-137 has a half-life of 30.2 years. 60.4 divided by 30.2, that's 2 half-lives. 60.4 is double this number, so it's 2 half-lives. So if we start with 100 grams, how much is left after 2 half-lives? Well, 100 grams would go to 50 in the first half-life, 50 grams would go to 25 in the second half-life. You're just basically making another one of these little charts showing what you start with and what you get at each half-life. You really have to just write it out this way. This is the simplest way to do these kind of problems. Isn't there a formula, Mr. Young? I recommend doing it this way, just writing it out and following the path of 1 goes to 1/2, goes to 1/4, goes to 1/8, etc. The half-life for the alpha decay of radium-226 is 1,600 years. I think in your reference tables it's actually closer to 1,599, but we'll call it 1,600. How many years must pass until 65 grams has decayed to 4.0625 grams remaining? Show work or explain how you figured this out. Let's show some work. We start at 65. After 1 half-life, we're at 32.5. 2 half-lives, 16.25. 3 half-lives, 8.125. 4 half-lives, 4.0625. Hey, that worked out. I guess they wanted us to have it work out perfectly to some number of half-lives. So that's 4 half-lives. And how many years is that? Okay, well, radium-226 has a half-life of 1,600 years. Sorry you can't see this. Let's hide this. 4 times 1,600 is 6,400 years. And again, I think in table N, this is actually 1,599, but that's really darn close. Okay, here's what's next. You're going to do the video worksheet about half-life. You're going to work on assignments 10 and 12. You may want to make some flashcards. There's some information in your one-page guide, or there's a list on Google Classroom for ideas for what could go on your flashcards. There's also a little slideshow where you can quiz yourself or quiz a friend with questions. And you're going to hit pause, and then when you come back to me, I'm going to go over the half-life check-in sheet. Okay, I'm not sure what color it is, but it'll be called the half-life check-in sheet. All right, get to work. Okay, here we are on the half-life check-in sheet. Let's see if we can solve some of these problems. What radioisotope undergoes beta decay and has a half-life of less than 1 minute? Half-life of less than 1 minute. Wow, that's really short. Let's see, I'm looking at table M, trying to figure it out. It undergoes beta decay, half-life of less than 1 minute. I'm looking for something with a really short half-life. Hey, I see francium-220. It's got a half-life of just 27 seconds. And no, it's not, but it undergoes alpha decay, so it's not that one. Let's see. What's really short? Beta decay. We're looking for one that undergoes beta decay and it's a half-life. Hey, I think I found it. Nitrogen-16. Found it. Nitrogen-16. Because it has a half-life of 7.13 seconds, and it undergoes beta decay. Beta decay. That's just electrons. After 32 days, 5 milligrams of an 80 milligram sample remains unchanged. What is the half-life? Okay, so after 32 days, we've got 5 milligrams left. What is the half-life? Okay, so we're going to have to make a chart. We start with 80, and then after one half-life, we've got 40, and after two half-lives, we've got 20, and after three half-lives, we've got 10, and after four half-lives, we've got 5. So how many half-lives passed? 1, 2, 3. That's 4 half-lives. 32 days is 4 half-lives. So 32 divided by 4 equals each half-life must be 8 days. Okay, because 32 days was how long it took to do 1, 2, 3, 4 half-lives. Number 3, based on table N, what fraction of strontium-90 would remain unchanged after 58.2 years? Okay, find strontium-90 on table N. Where is it? It is about close to the bottom. Okay, the half-life is 29.1 years. That's the half-life, 29.1 years. What fraction will remain unchanged after 58.2? Well, that looks like double this number. That's 2 half-lives. So after 2 half-lives, how much would be left? Well, 1 goes to 1 half in 1 half-life. 1 half goes to a fourth in 2 half-lives. Remember, we start with 1, then we go to a half. That's the first half-life. Then we go to 1/4. Which fraction of an original 20-gram sample of nitrogen-16 remains unchanged after 36 seconds? Wow, nitrogen-16 must decay pretty quickly. Oh yeah, we said it decayed pretty quickly. 7.13 seconds is our half-life of nitrogen-16. What fraction remains unchanged after 36 seconds? Okay, so well, let's see how many half-lives. I'll do 36 divided by 7.13. And is that going to work out perfectly? Let's see. Let me pull out my calculator. I'm trying to do this really fast. I'm pushing the wrong buttons. Okay, 36 divided by 7.13. Exactly 5 half-lives. Okay, I guess they made that work out nicely. That equals 5 half-lives will have passed. 5 half-lives. Okay, and so that means we start at 1. 1 goes to 1 half. Half goes to a fourth. Third half-life brings us to 8. Fourth half-life brings us to 1/16. Fifth half-life brings us to 1/32. Okay. And let's see. Bring us ahead. Cesium-137 is stored in a waste container in Yucca Mountain. How much time must elapse until only 1/16 remains unchanged? Okay, 1 to 1 half to 1/4 to 1/8 to 1/16. How many half-lives? 1, 2, 3, 4 half-lives. 4 half-lives. Okay, and so how much time is that? It's cesium-137, okay, which has a half-life of 30.2. 30.2 times 4 equals 120.8 years. If a scientist purifies 1 gram of radium-226, how many years must pass before only 0.5 grams of the original sample remains unchanged? Okay, we'll start with 1 gram. Okay, this is 1 half-life. So we start with 1, and we end 1 gram, and we end up with a half a gram. Okay, so what's the half-life of radium-226? 1,599 years. And finally,